It is estimated that 100 billion meteors strike our atmosphere every 24 hours. Nearly all of these are extremely small, no larger than a minute grain of sand, and are burned up by friction with the air, and only their ashes fall to the earth. Occasionally, however, a meteor large enough not to be entirely consumed will come through the atmosphere and actually strike the earth. A total of around 1,500 meteorites are known, and about one-third of them are represented in the collection of the American Museum of Natural History. Such collections represent the only concrete messengers from space that come to the earth. The largest known specimen at Grootfontein in southwest Africa is estimated to weigh about 165 tons. For masses such as this and larger, the impact is terrific. A large body weighing many tons will pierce the atmosphere without being appreciably checked and crash into the ground, while moving from 10 to 60 miles a second. In comparison, a rifle bullet's velocity is about a half mile per second. As the mass plunges into the ground, its forward motion is checked in a small fraction of a second. The contacting parts of the meteor and the ground are tremendously compressed, heated, and partly vaporized. This gas and steam from groundwater expands in a terrific explosion, tearing a gaping crater in the earth. About a dozen large craters have been ascribed to meteoric impact. The first crater determined to be of such origin was the Meteor Crater in Arizona, officially known as the Barringer Meteor Crater, after the owner, Daniel M. Barringer, who with considerable difficulty convinced scientists of his theory of the crater's origin. It is located in Coconino County, Arizona, about 20 miles west of Winslow and 35 miles east of Flagstaff, and fortunately for tourists, just about a half a dozen miles south of U.S. Route 66 on a modern paved highway. These movies and the meteorite collection on display at this meeting were a gift to the Black River Astronomical Society by the family of the late Debret D. Bernhardt of Lorraine, one of the founders of our organization. Bernhardt made his first visit to the crater in 1948. He was so fascinated by what he saw that he returned 4 times. On his second and subsequent visits, he arrived equipped with magnetometers and metal locators. His enthusiasm paid off in the results evident in our display case, which represents less than half of his findings, since he was obliged to give the best specimens to the owners. Bernhardt was fond of recounting the incident of his first attempt at using the Army mine detector. Within a very few minutes after having started to sweep the terrain with the search coil, a very strong signal was heard in the earphones. Frantic digging and scraping to a depth of several inches revealed a slightly oxidized pork and beans tin with a well-preserved Campbell's label. Our largest specimen originally weighed more than 13 pounds. Bernhardt sawed, polished, and etched both pieces to show the Widmanstatten lines. The larger piece was returned to the crater, where it is now on display in the modern museum and visitors center recently built at the northeast rim of the crater. In evidence of the enormity of the collision, the crater, situated in a large level plateau of stratified limestone and sandstone, nearly circular, averages 4,100 feet across. The present depth from rim to crater floor is about 600 feet. The rim, 120 to 160 feet higher than the surrounding plain, and 1.5 miles in outside diameter, can be seen from